Hello, today I will be talking about our autonomous driving research project. We used Udacity to gather data, so entering training mode. We started by first recording to the folder to where our code is, right here, but for the sake of the demo, I'll just pick a random one. So we start recording, and I'm trying to collect some good data. So what I'm doing is I'm manually controlling the car, and I'm going to attempt to collect data that is ideal so that it won't confuse our algorithm. So after we've collected enough data, and has to be good data. So once we've driven enough and we're sure that it's good, we're going to capture. So since this is a demo, I'm not going to wait for it to capture, so I'll just hit exit right here. But basically, Udacity saves that recording as images of the environment as well as inputs that I entered, such as left, right, throttle, and brake. So it gets saved as this data folder right here within this directory that contains the rest of the code. So now I'm able to run this program right here, model.py. I'm able to run this program that references this data that I collected, and this data that we collected. So this is where we start to train our computer to drive properly. So I'll run model.py, and it's going to start training itself. So for the sake of, to help you visualize what the computer is doing, I'm going to enter training mode, but don't be confused. This is just to make it easier to visualize. So what the computer is doing is it basically runs through this track, inputting a whole bunch of random inputs. And it's typically very bad. And it compares that drive to the perfect user data that I collected at the beginning. The difference between the computer's attempt and the user data is called loss, which is what you see right here, where a greater loss means a worse attempt on the computer's part. Right now, it is trained to recognize which actions lower the loss value. So for example, if the computer randomly hits a control combination that allows it to stay within the traffic lines, that would be similar to the user data, and it would generate a small loss. On the flip side, if the computer randomly hits a control that makes the car fall off the side like this, that heavily deviates from the user data we collected. And that would result in a very great loss. So the computer notes which inputs made the smallest loss possible and saves its progress before moving on to the next level, or epoch. So now we're on epoch 1, and now we're going to go to epoch 2 once it finishes loading. So now the computer repeats the process, it restarts this, and it attempts another drive around the track, but initialized with the last run in mind. So it begins moving in accordance to which inputs cause the smallest loss. This process repeats over and over again, and as a result, the computer gets slightly better with each epoch, with the loss generally decreasing over time. Once we get to the last epoch, which could take over a day depending on your computer, we take the most recent and best model that got saved. So what I'm going to do is I'm going to cut this training algorithm short since it's just a demo, and now I'm going to find my most recent model and run it. Let's see. So model 15, I'm going to run it. What I'm going to do is exit out of this demo right here. Fun fact, this model had 15 epochs and took over 9 hours to train. So now I'm going to enter autonomous mode. And test what this model's performance is like. This is the computer's attempt at mimicking the user data as closely as possible. And it's completely autonomous. I'm not controlling it in any way right now. This model was able to go over 10 laps around the track without a single crash. And probably could have gone even longer since I left after 10. After, I'll be showing comparisons of each model's performance at different epochs level. So you can just see how the computer is running for now.